Okay, let's jog your memories. Guys, come prepare to class. If there's something I say, memorize, study, you need to master it before you come to class. Okay, who, if anybody remembers the definition for displacement?
Change in position of an object.
Thank you. It's a net change in position of the object over 1 to 3. So what's my notation?
S of
X of 3 change in position. S of
Minus
1.
Which
So
is
what's the question we should ask ourselves?
Is there a mismatch?
Is there a mismatch? Therefore, will net change kick in?
Yeah.
yes.
Yes.
Integral
1 to 3.
And
T.
S
dash of t should have what?
T
Is dash of t dt, which is just
V
a of t. So integral, I'm just getting ready to plug it in, yeah? So at this stage, now look here, at this stage, are we integrating or just plugging in?
we're integrating.
We're integrating, hasn't integrated simple. There's no confusion. It says integrate. Exactly, yeah. We plug in and we integrate. Can we move on?
Yes.
Okay, the next part of the lesson is we're doing interpretations, okay? If you attended office hours yesterday, you got an advanced peek at the concept. So don't write this, don't write this. So I'm just going over basic interpretations. If you see the phrase change in, change means different, so it's f of b minus f of a. And backwards, conversely, if you see f of b minus f of a, that's change in f of x over a to b. If you see the expression average rate of change, please understand that's different from average. It says average rate of change. So that's msec. That's f of b minus f of a over b minus a. Conversely, if you see f of b minus f of a in red, that means average rate of change of f of x over a to b. And finally, if you see the expression average or average value of f of x, it's the integral formula. Or if you see that integral expression, it means average of f of x. This is a quick review. Now let's discuss units. Right on page 5, interpretation and units. Now we're actually doing examples. Write down, we're on page 5.
Okay.
It says interpretations and units. So write down f of b minus f of a is the change in f of x over a to b. Write that down. And then write down your notes. Write down your notes. It'll have the units of f of x. If I say what's the change in temperature, can you see? You'll just say Fahrenheit. You're not saying Fahrenheit per minute. You're not like weirdly changing it. So please make a note. The units will just be that of f of x, whatever the function is. If we give you temperature, it's Fahrenheit or Celsius. If we give you weight, then it's pounds or kilos or whatever. Okay. So keep that in mind. All right. Now in your notebook, just write down this. Okay. We're going to interpret it, write an English phrase. Do this with me. So it says a of 12 minus a of 0, where a of t stands for the acceleration of the object measured in meters per second square. So we will write an interpretation with the units. Okay, go. So what does that expression remind you of?
Changing.
Okay. There's a
Acceleration.
net change in
Acceleration.
acceleration of the object. Now teaching good habits in. Okay, what would your units be?
Meters.
There you go. It's just that function. It's meters per second square. Over the interval
0 to 12.
0 to 12, and that is measured in seconds, correct? That's fine. Okay, I'm giving you the units. I'm giving the units of that interval. It's time, so it's seconds. It's that easy, guys. It's that easy. Interpret literally. You don't have to say, oh, that's average. But where is average coming from? It just says a of 12 minus a of 0. Let's do another example. Write that expression down. Okay, read the rest of the sentence. You understand what the context is. It's a little weird, but that's okay. So R stands for the rate of change of the population of mice in a culture measured in mice per hour. Okay, so that expression reminds you of
Net change.
net change in the
Rate of change.
thank you, rate of change. Very good. Rate of change of
The population.
population of mice. Don't be lazy. In a culture measured in
Mice per hour.
miles per hour. It's just the same units. You don't have to overthink it. Over the interval,
5 to 10.
units,
Hours.
Hour.
Hours. The time is measured in hours. It's that easy, guys. Okay. Let's do the next set of interpretations. Right on page 6. So it says, if you see the expression, write it down, f of b minus f of a over b minus a. It is the average rate of change of f of x over a to b. Now pay close attention. We went over this yesterday during office hours, but I'm repeating myself. Can you see m sec is actually a rate of change? So it's the derivative. So the units will be the derivative of f of x. Write that down. So this is the only weird guy. The others are straightforward. So this is the only guy that you have to be careful with the units. This is like m sec, m tan. They're slopes. So you have to give me the slope derivative. Sorry, slope unit. Relax, it's easy. Okay, in your notebook, write down this expression. So we're going to interpret it using English. Do not, oh, by the way, there's a typo. That's supposed to be S, right? I have to fix it. That's page, is that page 6?
Yes.
Yes.
Thank you. Okay, do this with me. So that expression reminds you of,
Average rate of change.
Average rate of
thank you, average rate of change. Do not overthink it. Which function? Of
Position.
the position. S stands for position. Position of the object. Okay, let me model good behavior. In, stop. Think before you answer. What would the units be? Hint, we just learned for average rate of change, it's the unit of the, it's the unit of the derivative. And
Velocity.
the derivative of position is
Velocity.
velocity. So what should the units be?
meters per second.
B.
Meters per second. Okay, I should have said S in meters, correct? So meters per second or kilometer, whatever. So it's meters per second. And then over the interval,
4 to 14
4 to 14.
4 to 14
seconds.
seconds.
Second.
Okay. Okay. Let's do another one. Copy it on the bottom, guy. So let's write the interpretation. It is the
Average rate of change.
Average change.
average rate of change of
Population.
Population of mice.
Of the rate of change.
Thank
Rate
you.
of-
Is it in the function R, which is rate of change? Is the average rate of change of the rate of change? Careful. It didn't say P, it said R, correct? Rate of change of the population mice. Be attentive, please. In a culture. Okay, now stop. Now, R is measured in mice per hour. So if you're attentive to the lesson, what would the unit be?
Mice per hour squared.
Thank you, mice per hour square. Because of the derivative. Let's wrap it up. Over
5 to 10 hours.
hours. So pay close attention. The only tricky unit is where you see MSEC. Is that clear? Because MSEC is the slope. So we're finding the slope of R from the first chapter, first semester, mice per hour square. Okay, last interpretation, right on page 7. So it says 1 over b minus a, interval a to b, f of x dx. Write down your notes. It's the average of f of x over the interval a to b. And the units is very simple, is just f of x, just like net change. It's just the unit of f of x. Do not overthink it. So if I said, what's the average weight? You just give me 150 pounds. Do not say 150 pounds per hour, something weird like that. Whatever the function is, it's just that in units. Okay. All right, let's do a couple of examples. Copy down the expression. Okay, go. It is the
Average
Average.
Oops, sorry. It's the average
Of velocity.
of velocity. Guys, do not overthink it. Don't say position, don't say acceleration. Where are those coming from? It's average of the velocity function. So average of velocity, or the average velocity of the object in
Miles per second.
miles per second over the interval
2 to 6.
2 to 6
Second.
seconds. It's that easy. Okay, for independent practice, do this all by yourself. Go left to right, observe what R stands for, write an interpretation with the units. Do this independently. Do not be sitting idly. Okay, Soprano, have a shot. Soprano?
Denotes the average rate of change.
Again, silly girl, are you even paying attention? Why are you writing average rate of change?
Oh, the average.
Why? Why are you writing average rate of change? Does this remind you of the MSEC formula? Why are you writing average rate of change? Where is that even coming from? We learned 3 interpretations. We did average rate of change, which is the MSEC formula, net change, which just means difference, and then you have an interval, that's the 1 over b minus the integral, that's average. Okay, it is the average of
The amount of fruit.
no. Okay, okay. I think I understand. Okay, you were missing the word average. Otherwise, you're okay. So it's the average of.
Wait, I'm lost now.
No. It's the average of.
The amount of fruit.
No. There is no amount here.
Oh, denotes the rate of change.
The rate of change. I wanted that word off, silly.
Yeah.
Guys, before I move on, I want you to understand my confusion with what Ms. Soprano said. She's not incorrect. Okay, so she said average rate of change. Do you understand why I might be thrown off?
Yeah.
Oh.
Correct? So it's the average of the rate of change. Now, if you do not write the word of it will not mark it down. You would confuse students, confuse us if you say average rate of change. It's the average of the rate of change of the amount of fruit on the shelf. Of a store. Soprano, what's your units? In?
Pounds per minute.
Again, it's just the units, guys, of R. Over the interval.
1 minute.
Minutes? Is that clear? Was that easy? So let's go, guys, pencils down. So which is the only one that had slightly confusing units out of the 3? So we did net change, average rate of change, and average. Which is the only guy that you have to be careful about units?
Average rate of change.
Average rate of change, because the average rate of change is a slope. You have to give me the slope of that function. Just be attentive, okay? Let's do a mixed review. Right on page 8. I'm mixing it up now. Okay, so we did discuss 2 of each kind. Being a good teacher, now I'm mixing it up. Okay, in your notebook, just write on that expression. Okay. Sorry, we're on page. Guys, we're on page. Your mom. Sorry, page 8. We're on page 8. It's a Rama classic. Okay, we're on page 8. Write on that expression. Okay, I'll give you 3 options. Choose wisely. Do not speak for 10 seconds. Those of you got the hang of it, you can run ahead. So, is that average? Is that average rate of change or net change? Don't speak. Okay, Mr. Hernandez, which of those 3 is it?
Average rate of change.
Love you, man. So it's the average rate of change. Let's start writing down. So it's the average rate of change because it reminds you of the MSEC function. Of
Volume
of
of
the,
tank.
Of the volume of water in the
there
tank.
you go. Get it from the question. The volume of water in the tank. In what are your units be?
Oh, in gallons?
Ms. Gatsella?
Gallons per minute.
Okay, Mr. Hernandez, don't forget. Average rate of change, you give me the units of the slope. So it's gallons per minute. Over the interval,
50 to 100.
minutes. Okay, check if you got that. Miss Julian, you're doing okay?
Yes, I'm doing.
McQuarter, please attend office hours. I missed you yesterday. McQuarter. Bad girl. Sorry, what did you say?
I said okay.
Okay, guys, let's do another one. Copy down the next expression. Now I'm checking how many of you have good memories. Okay. First of all, do we have? I'm just checking for good memories. Anybody remember what that guy reminds you of?
Average.
No, it is not average. You don't have a 1/2 being manager.
Displacement.
Displacement. She's coming prepared to class. This is the integral velocity displacement. But otherwise, I'm showing a trick. Otherwise, who said displacement, by the way?
Miss Holdenauer.
This who?
Miss
Poldenauer?
Mhm.
Okay, good girl. Love you. Guys, she remembered the integral velocity is displacement. But otherwise, for the rest of the kids who are not as prepared, can you see we don't have an interpretation? But smart kids, we can write V of t as dash of d. So you're learning a concept. If you do not know an interpretation, rewrite using that change. Therefore, the right-hand side becomes
S of 5 minus S of
S
2.
of 5 minus S of 2, which reminds you of which interpretation?
Net change.
Net change.
Position.
Position. It's a velocity. It's S. So it is the net change. We'll write two definitions. So it's a net change in position. Or, as Ordonez smartly said, it's the displacement. You can write both on the AP exam. Of the object in, what do the units do? In its position or displacement.
Meters over minute.
No. We're writing the units of position.
Oh, it would be just meters.
Just meters, okay? Not the original. The meters per minute is velocity. We want this thing for position, correct? In meters over the interval
2 to 5
minutes.
minutes. Is that clear? Okay, do the last all by yourself, independent practice. Write me the units also. I mean, no rush. Okay, Ms. Meena Habshaw.
Average number of attendees at a convention in hundreds over 3 to 15 closing arrow.
Hours. Okay, guys, you may not you may not have heard her. I have super sharp hearing. That was Meena shouting, by the way. All right, that was Meena being super excited and shouting her head off. So I'm doing gentle of this Meena. This is Miss Meena on an amusement park ride. Guys, this is Meena not even in Disneyland. This is Meena in Six Flags. This is a big park ride. Okay. Oh, Miss Meena, how are you finding the ride? This is Miss Meena. Yay. Yay. That's Meena really excited and shouting her head off. So seriously, I'm just teasing Meena. It's the average number of attendees at a convention. In hundreds, that's the unit. Over the interval 3 to 15 hours. Okay, not easy. Definitely got that yourselves. Right. We do the others if you attend office hours. We do more examples. I have lots of examples. Okay. Let's do problem setup. We're doing a mixed review for the next 10, 15 minutes. Write down page 12, please. Mr. Buhe, how are you doing?
Good.
Okay. Guys, this is page 12. So copy down this. And then copy down that. So you know what the question was. Okay, first step, I'm giving you good habits. Interpret the problem exactly the way it's written. Do not overthink it. Interpret it literally. Okay, Ms. Vasquez, have a shot. What are you writing? Ms. Vasquez, unmute yourself, please. Vasquez, are you there? Okay, Ms. Carlos, pick it up.
S of power over 2 minus.
How do you? It says average rate of change of position. So Ms. Carlos smartly says S, pi over 2 minus S of 0, all over
2.
pi over 2. Stop. What's the question we should ask ourselves?
Is there?
Is there a mismatch? Okay, is there a mismatch?
Yeah.
Yes. So net change will kick in. See, this comes back to you. Can I pull out the 1 over pi over 2?
Mm-hmm.
Okay. All right. Ms. Carlos, continue. What are you writing in parentheses?
S of power over 2 minus S of 0.
No.
Wait.
You're not writing S of pi over S of 0 again in parentheses. You should apply net change. How does net change work?
Oh, the integral?
Yeah.
Oh,
Integral.
yeah. Integral from 0 to pi over 2. And then S dash 50.
There you go. What is the use of the if you just copy it down twice? It's not moving you on. You just S of pi over 2 minus S of 0 again. How is that helping you? Okay. Ooh, guys, what is S dash in front of you? V of t. And do we know V of t? 1 over pi over 2 becomes
2 over pi. 2 over pi.
multiplied by the reciprocal. Integral from 0 to pi over 2. Copy down. Okay, we will only integrate, we will not plug in. Okay, D2, don't forget the operator. Okay, Mr. Buhe, have a shot. What's the integral of sine t?
3 times negative cosine t.
You mean 3t?
Yeah.
Is it 3 times?
Oh no, divided by 3.
So negative 1/3, right?
Yeah.
Okay, do the other one. So,
Minus 4e to the power of negative 2t divided by negative 2.
okay, guys, be careful. For integrals, you're dividing, okay? Low limit 0, upper limit pi over 2. Can we move on? Okay. Guys, I'm focusing on the important idea, which is setup. Can you see setup is the challenging one? Okay, right on page 13. Okay, do the first step yourself. Interpret the problem literally, exactly the way it's written, not overthink. Okay, Ms. Bishop, have a shot.
AV equals 1 over 7. 1 over 8, sorry.
Continue.
1 over 8, bracket, integral, lower limit 3, upper limit 11, V of t dt.
Again, it says average velocity. Very good, Ms. Bishop. Interpret literally. Do not overthink it. Don't say S of t. Where is S coming from? It says average velocity. Guys, is there a mismatch?
Yes.
Yeah.
Yeah. So we can write V of t as
S dash
dash of t. Okay, write me the right side yourselves. Write me the next step yourself. Go on. Okay, Ms. Sarango, what are you writing?
1 over 8, bracket, integral 3 to 11. And then would it be This was the one I messed up on yesterday. Would it be S of 11 minus S of
No. Guys, when you're going from one form to another, everybody, look at the board. Everybody, look at the board. Everybody, look at the board. So look at the previous problem. It said S of something minus S of something. So when you're going to the other form, you have integral. So look at this problem. We have an integral. So when we're going to the other form, you cannot write the integral. The integral should vanish. Okay, again, next chain says if you have integral of a derivative, then it's the function itself, upper limit minus lower limit. So do not write the word as integral again. That'll totally confuse you. Okay, go on, Tarango, start again. So 1 over 8.
1 over 8, would it be S of 11 minus S of 3?
There you go. Don't say integral.
My bad. I meant to like, because I was going to do something else and I was like, wait, this was the one I messed up on yesterday. So I remembered.
Okay. Guys, is there integration involved or just substitution?
Substitution.
Okay, just they give you S of t. Can we move on? You just have to plug into S. Sidebar, S of 11, S of 3, plug it in, simplify. Don't forget the 1 8. Okay, go to page 14, please. Okay, interpret the problem literally, exactly the way it's written. Do not overthink it. Okay, Ms. Makwara, have a shot. How do we interpret that phrase? Do not overthink it. We can't hear you, Makwara. You have to be louder.
We do the V of 3 minus V of 1.
Love you. V of 3 minus V of 1. That's it. Guys, do we have a mismatch?
Yes.
Okay, Makwara continues. So what are you writing on the other side?
And then that it's net change. So the integral.
Yes.
Yeah.
Guys, if you have a difference on one side, the other side becomes an integral. If you have an integral, then you have a difference on the other side. Ms. Tarango, observe the pattern. Okay, continue, Ms. Makwara. Integral.
Of 1 to 3, and then V dash of
Yes, V dash. Take the derivative. Guys, what do we know V dash at?
AFT?
AFT. So can we plug it in? Does this question require integration?
Yes.
Yes. Because it has an integral symbol right now. Okay. Okay, guys, now I'm showing you how to do a bunch of problems. We went over this in office hours yesterday, but we are doing a bunch of problems involving a calculator. So in today's homework, it'll clearly have a C next to it saying you're allowed to use calculator or Desmos. Write down page 15, please. Everybody, stay with me. Write on page 15. Now I'm informing you you're allowed to use a calculator. And I will just guide you. Most of these are stupidly simple, but the harder ones we'll actually do in Desmos. Okay, copy down this question. We need to accelerate. Okay, stay with me. Okay, stop. What do we ask ourselves first step?
Sir,
Mismatch?
Is there a mismatch?
Yes.
Yes.
Okay, so give me a right-hand side. Look down. Do not speak. Okay, Mr. Rango, what are you writing?
Would it be F of 2 minus F of 5? Wait. Right? Wait.
Other way around.
No, F of 5 minus F of 2.
Yeah, upper limit. Girl.
Thank you for remembering that.
Stop. Do we totally have f of x?
Yeah.
Yeah.
Okay, now pay attention. We're not doing it, but pay attention. Can you type that in Desmos? And then in the next row, just type that.
Yes.
Yeah.
Yes.
Yes? You don't have to do them separately. Type the original guy in Desmos in row 1 and just type f of 5 minus f of 2. You're good to go. Is everybody okay there? It's a stupid problem. Okay, let's move on. Right on page 16. Now we will actually do this in Desmos, so pay close attention. We will actually do this in Desmos. Okay, copy that, copy that, copy that. Okay, those of you coming prepared to class, they're giving you f dash, they're giving you a starting value f of 4 equals -1. The question says find f of 0. So what concept kicks in?
Net change.
Net change corollary? Okay, we're using net change corollary. So f of 0, so whichever the question is that we're finding. So f of 0 equals
F of 4
f of 4.
4 plus
Integral, pay attention. This is the lower limit.
4.
We go-
4 to 0.
Is it tempting to write 0 to 4?
Yes.
Yes.
But you need to slow down and think through the pattern. And the guy we need is on the top. F dash of x dx. Is everybody okay there? Okay, now can we plug it in? What's f of 4 given to be?
-1.
-1 plus integral 4 to 0 f dash of x, and you can plug it in. But I'm going to leave this as, say, f dash of x. I want to show you how to do this on Desmos. Okay, follow my lead. Follow my lead. I'm going to go, let's see if we can present here. Okay. I want you to open a new window. Go to Desmos. Okay, is everybody able to see my screen on Desmos?
Yes.
Okay, now I want to show you. Now, I did not teach this to the other class this way. I'm showing you how to do this. So type f of x. Pay attention. I'm just typing that as f of x. Is that clear? I'm not typing f dash. I'm just calling it f of x. Play along. So f of x equals x over 2 times sine e to the power of x. Is everybody okay there?
Yes.
And then in the second row, I will just now look at the expression. Is that -1 plus integral int? Repeat, the command is int. Lower limit,
4,
upper limit.
0.
And should I just type f of x dx? Does everybody understand why?
Yes.
Dx. Ta-da! Write down your answer. -1.0516. Do not forget to type -1 plus. So -1.0516. Is everybody okay there? So type the function as just f of x. Now in the other class, I had them type out the entire expression. Okay, I'm showing you what we did in the other class. In the other class, I showed them, write down or. We just wrote -1 plus integral 4 to 0 x over 2 sine ex dx. And the other class typed out this entire thing. Is it easier to just type f of x integral f of x dx?
Yeah.
Yeah.
Correct? So I'm switching. Just call the original function. I know it says f dash, just call it f of x and then just type it. Okay, let's do another example. But we'll do a harder one. Now, informing you, you have one question of each kind. So page 16, you write an asterisk. Page 16, you have a question like this on your chapter test. And then page 17, you have another question just like page 17. I'm informing you. And B, observe how dedicated a student Abdul Rahman is. She's making notes to herself saying, oh my God, these are important questions. I'm informing you that page 16 and page 17 are questions on your chapter test. So write on page 17. Relax, we'll get multiple opportunities of practice before we take the test. So copy that down. So this time, just like first semester, we're finding the
Equation.
equation of the tangent line to f of x. This is page 17, please. And x equals 8. Okay, relax. It's a stupidly easy problem. The calculator is going to do all the hard work. Okay, I need the equation of the line. What are the two things we need to write the equation of the line?
Point.
Point and slope. I hope you wrote down all the information given to us. So point, the notation. What's the x value of the point?
8.
8. The notation. What do I need? Notation. I need 8, comma,
1.
F of 8?
Y.
F of 8. I love you. F of 8, silly. That's F of 1 equals -2. That's just a random point given. I need the equation of line at x equals 8. So it's an 8 comma F of 8. Does everybody understand that? Oh. I know F of 1. I need F of 8.
Corollary.
She's having trouble pronouncing it. So are we using net change corollary again? So we know F of 1. I know F dash. I need F of 8. Make the connection, please. So F of 8 equals
F of 1
F of 1
Plus.
integral
integral
1 dx.
dash of x dx. Is everybody okay there? So what's F of 1 given to be?
-2.
-2 plus integral 1 to 8 f dash of x dx. Remember, we'll use Desmos. Okay, now I want all of you, switch to Desmos, type out first, f of x equals radical x sine of x squared over 4. Go. You're not sitting idly. Guys, I'm going to accelerate now. Hurry up. You should be working on this. Quick. So type out Desmos, clear the old guy. Top row, f of x equals radical x times sine of x squared over 4. Then type this entire expression. Be smart. Don't type f dash of x because the function is f of x. Those of you finished, what is the function? Give me the point. Quick. I need everybody to work. Do not be sitting idly.
I got 0.2095.
Somebody confirm that.
Yeah.
Thank you. So I'm being a good teacher. So you're basically 8, 0.2095. Is everybody okay there?
Yes.
Next, we just found the point. What else do I need? I need the equation of the line.
The slope.
Okay, what's my notation? What's my function notation? It's not a trick.
Double that?
Dash.
Is that f dash at 8? Is everybody okay there? I need f dash at 8. Stop! What do they give? What do they give you?
F dash of x.
F dash x. So what do I just need?
Plug in 8.
Plug in 8. So when in your Desmos,
Plug it
haven't we already called that function f of x? So in simple language, do I just need f of 8 then?
Yes.
Okay, and if you're not able to make the connection, everybody look at my arrow. That's f dash of x. I just need f dash of 8. I'm just going to plug in 8 there. So have Desmos do it. Tell me what you get.
-0.814.
Somebody confirm that.
Yeah.
Okay, guys, just to be clear, in Desmos, am I just typing f of 8 or f dash of 8? Which one am I simply typing?
F of 8.
F of
F of 8, because the original function was f dash. Be alert. Okay, is anybody confused or lost? This is the time you tell me. Carlos, are you understanding what's going on?
Yes.
Is Meena?
Yeah, I am.
Ms. Makwata?
Yeah, I'm kind of.
Ms. Bergen?
Yeah, I'm getting it.
Okay, final step. Guys, we're writing the equation of a line. So how do we always write the equation of a line? Let me guide you. Y minus
y minus
0.2095
equals
equal to -0.814 x minus 8.
ta-da! It's that easy. It's that easy. So before we leave, observe why this question was slightly more interesting. I needed a point and a line at 8. Some of you are focused on the 1. I don't care about the 1. I need the equation of tangent line to f of x at x equals 8. So we find the point, which is 8, comma f of 8. Ooh, net change corollary. Yeah, tricky question. Then I need the slope. They give you f dash. Okay, I can just plug it in. We're good to go. Okay. Back to page 18, please. Okay, we'll set it up. Ms. Uduman, tell me what to write.
AV
equals
1/4
very good. 3 minus -1.
integral -1 to 3 f of x dx.
Everybody, look at the board, please. Is there a mismatch?
No.
No. Are we just good to go? Are we just good to go?
Yeah.
This is me showing you not every problem is there a mismatch. Can we just plug in? Oh, by the way, it's just a calculator problem. So is it stupidly simple?
Yes.
You can just type f of x and then just do integral 1/4 integral -1 to 3 f of x dx and you're good to go. It's just a calculator problem. Okay. Let's do another one. Right on page 19. Stay with me. Do not fall behind. Morales, are you having better work habits? Are you keeping up with your homework? Every day?
Yes. Yes.
Good girl. Okay, guys. We're doing 19. Stay with me. Okay, Vasquez, are you there? Vasquez, are you there? Okay, forget it. Oh, you're there now, finally. Okay, Vasquez, if you interpret the problem exactly the way it's written, tell me what to write.
The average rate of change. So wouldn't it be f of 3 m sec equals f of 3 minus f of -1 over 4?
Okay, everybody, is there a mismatch?
No.
No.
No. So it's just stupidly simple. Okay, I don't wanna, this is from the first semester. Everybody, I'm teaching you good habits. Girls especially, because I love you people. I'm showing you how to type this on a calculator. Everybody, see this comes back from the first semester. When you're typing the decimals, can you please make sure you have a parentheses there? So PEMDAS, order of operation, fix it. Yes? Okay, we're not going to do it. I'm just showing you. It's a stupid problem. But make sure you put parentheses on top. So order of operation, fix it. Okay, next. Right on page 20. Now you have a whole bunch of these problems on your homework. Ms. No said the homework is insanely easy. Okay, Miss Julian, have a shot.
Average rate of change equal f of 4 minus f of -1 over 5.
Okay, Miss Julian will stay with you. Do we have a mismatch?
Yeah.
So tell me what to write next step.
So do we write integral and is -1 and then f dash of it? Yeah.
Guys, see if this comes back. Should we pull out the 1/5 like this?
Yes.
Yeah, good habits. Pull out the 1/5. Okay. Can we now just type that in the way we see it on your calculator on Desmos?
Yes.
And we can call this f of x, right? We can just call that f of x and type that in. Yeah, everybody okay there? Okay, just call that f of x. Type that in. We're good to go. Okay, now we're learning something brand new. Okay, right on page 21. Everybody, page 21. You do not need to copy the table. Do not copy the table. Just write down that expression. It's a stupidly easy problem. It says use the table to find the value of. We have discussed questions like this before. So if I say in the future, because you'll have a question like on your test. If I say in the future, how do we do this? You will, just like a piecewise function, you'll use a magic phrase, Rama, split up the interval. Okay. You'll say split up the integral and you get to go. We have done this for limit problems, we've done this for derivative, and we're doing this for integrals. I'm going to write something on the board, look at it and say, oh, yeah, this comes back to me. So I'll do the first term, you guys follow the other one. So I'll pull out the 2, I'll just distribute the integral. 3 to 7, h double dash of x, dx. Okay, go. Tell me what to write.
1.
Oh, it's h dash of
1 second.
minus 3 integral. And then h dash x.
Dx, don't forget the operator. I'm just splitting up that integral. And then for the last guy, it's just number 4. That's just 3 to 7, 4 dx. Is everybody okay there? I just split up that integral. Okay. 2, stop. I have to find integral of h double dash. And the table gives me h and h dash. So in simple language, there's a mismatch. So smart kids, what can I write? Integral of h double dash. Tell me what to write.
it's h dash of the 7 minus h dash of 3.
Is everybody okay there? Using net change. Next, I need the 3 to 7 integral of h of x. I do not have an integral of h of x. Therefore, I can write integral 3 to 7 h dash as.
H of 3 or h of 7 minus h of 3.
Is everybody okay there? Net change again. Plus, smart kids, don't get lost. 4 is just a constant. What's the integral of 4?
0.
4x.
Okay,
Correct.
we're getting integrals. 3 to 7. Okay, let's wrap it up. Ooh, read the table. What's h dash of 7 given to me?
10.
Minus h dash of 3.
5.
Very good. Minus 3. What's h of 7 given to me?
22.
22 minus
7.
7.
plus. Okay, now we are plugging in upper limit. 4 times 7
28.
minus.
12.
Ta-da! Was that stupidly simple?
Yep.
Okay, so I was showing you how to apply net change using a table of values, and that's okay. Okay, right on page 22. Everybody write on page 22. Okay, I'm letting you know this is the new bulk of the lesson. Okay, moving forward, 10 to 10:30, we're doing brand new stuff. So pay very, very close attention. Okay, put your pencils down. It's a word on. So I'm going to direct. If you were here, kids, if you were here during office hours yesterday, you got an advanced speak of the problem. I love you kids who attend office hours, even when it's not your day, because you're getting an advanced speak of the problem. Okay, read it with me. This is from the first semester, but I'm emphasizing a concept. Read it with me. The amount of shrimp. Oh, by the way, that's page 22, by the way. Okay, the amount of shrimp at a restaurant buffet is changing at a
Right.
rate of R of t in pounds per minute. Stop. From the first semester, and we have a word problem, and we have a rate. Who remembers how we set up these problems?
80.
Let A of t, I love you. Let A of t be the
Amount?
The
amount of shrimp at the buffet at time t. And the amount would be measured in pounds, correct? Who remembers what we wrote next step to set it up still?
A dash of t. Which
A dash of t is nothing but
The rate?
R of t. We just sine of e to the power of t over 2. They're giving you that. And is that the rate of change? See if this comes back. It's there on today's homework. So I'm making I'm tying up a concept from the first semester. Rate of change of the amount of shrimp. And that's measured in pounds per minute. Okay. Now read on with me. I'm putting a bracket so you can focus. It says initially there are 20 pounds. Look at the units. If initially there are 20 pounds of shrimp in the buffet. So what are they giving you indirectly? If initially there are 20 pounds of shrimp.
AT?
A of 0.
80.
Love you. A of 0. The time is 0. Initially means time is 0. Equals 20 pounds. Is everybody okay there? And let's read the last sentence. Find the amount of shrimp at 3 minutes. What are they asking for in notation? A of 3. Is everybody okay so far? Okay, because I'm aspiring to be a good teacher, I want you to read the paragraph and look at what we wrote once by yourselves. Give it 30 seconds. Do not speak. I'm in no rush. Feel free to ask me clarifications. So the question says the amount of shrimp is changing at a rate. You say, hey, wait a second, word problem with rate. You set up the original function, let A of t be the amount of shrimp. So if you see the word number, volume, it's just amount. Just say amount. Population, those are all amounts. So let A of t be the amount of people, the amount of water. Then A dash of t is R of t, is the rate of change. A of 0, initially there are 20 pounds. A of 0 is 20. Find the amount of shrimp at t equal. Oh, they give you a starting value and they give you a derivative. So what can I do?
Net change quality.
A of 3 is
A of 0.
A of 0.
Integral 0 to A dash of t.
Oh, what A dash after all?
R at t.
R.
R of t. And A of 0 was 20 pounds. Can I totally use Desmos to answer the question?
Yes, sir.
Do we need to do it? Or you guys say, yeah, we're okay?
We're okay.
We're okay. You can just type R of t in row 1 and just type that in 20 plus 0 to 3 R of x dx. Everybody okay there? Guys, make sure old rules. Type it as R of x dx. Yes? I hope that comes back to you. Okay. Let's do another problem.